In Unit 4, our focus is going to be on statistics. We want to know how to look at data and analyze it. Let's start with some vocabulary. We're going to analyze data, and data are facts and statistics that are collected to help us learn about something. We see statistics in nature, we see it in sports, in medicine, in business, just about everywhere you look in the world you see statistics. One of the first things that we look at is the mean. Mean is just another word for average. You know averages when you average your grade. You add up your grades and you divide by how many grades you have. And we can do that with any kind of data to find the mean. We add the values in the list and then we divide that sum by how many items are in the list. Median is another way to talk about a middle value. It's similar to the mean, but it's not always the same value. To find the median, you put your list in order from least to greatest, and then you find the middle value. If there are two numbers in the middle, then you average those two numbers. You add them together and divide by 2. The mode is the value that occurs the most in the list. Not every list will have a mode. The range is the difference between the largest and the smallest value in the list. In other words, the maximum minus the minimum. An outlier is just a value that's unusual in the list. Either it's way bigger than any other value or it's way smaller than any other value in the list. Let's look at a set of data which describes the length of 6 naps that Mr. Bruss took over a 2-week period. This data is given to us in minutes. To find the mean, we're going to add up all the values in the list, and when we add these up, it equals 270. And then we're going to divide by the number of naps that he took. So 270 divided by 6 gives us 45. So the average length of his nap is 45 minutes. The mode is the number that occurs the most, and we see that 45 occurs twice, whereas every other length of time occurs only once. So the mode is 45 minutes. The median is the middle number. Our list is already in order, and if we mark off from each end, we see that we have 2 numbers in the middle. So to find the median, we have to average those. Now we could add them and divide by 2, but it's pretty easy to see that halfway between 44 and 45 is going to be 44.5 minutes. So that median is very close to our mean, but they're not exactly the same thing. The median tells us that there are just as many naps longer than 44.5 minutes as there are naps that are shorter than 44.5 minutes. Now to find the range, we're going to take the longest nap, which is 58, and subtract the shortest nap, which is 38. So the range is 20 minutes. Now pause the video and find the mean, mode, median, and range for Mr. Bean's 6 naps over that same period of time. Even though we have different data values, when we add them up, we get 270, and when we divide by 6, we get 45. So our average, or our mean, is 45 minutes for this data set. There is no mode because each number occurs only once. The median is 36 minutes, which comes from adding the 30 and 42, the 2 numbers that are in the middle, and dividing by 2. And the range is 82 minutes, which comes from taking our maximum value of 100 and subtracting 18 from it. You can find these values by hand, but we're going to take advantage of Desmos.com and technology to find these values for us. So I've given you the keystrokes here as reminders so that you can refer to it when you're not watching the video. This is the same Desmos calculator that we use for graphing, but we don't want to put an equation in, we want to put a list. To put a list, we're going to have to add a table. So we go to the plus sign that's in the upper left, and then go down to Table and select that. Now my keyboard popped up, but if your keyboard does not pop up like that, then just know that you have an icon in the lower left, and you can pull up that icon for the keyboard. And then, even though we just have a list of Y values, we're going to have to put this in a table, which means we're just going to number our items on the X column. So my data is actually in the Y column of my table. Now I want to press enter after the table to get to the next line. And then to get to the commands to find the mean, I'm going to press the function, which is over to the right, and you get this menu. Now it may start out on trig, but you just go over to stats and select that. And to find the mean, we use that button for mean, and the command shows on the line. And then we're just going to tell it we want Y1 and press enter. As we do that, you see the little box in the lower right corner of that entry line that tells us the mean is 45. That's exactly what we found it to be. We can go back to functions and we can choose median, and again we need to tell it Y1 is where our data is, and you see in that lower right corner it tells us that the mean is 44.5. We can use the information about mean and median, mode, and range to tell us something about our two data sets. We can see that Mr. Bruss took more consistent naps. His data was closer together. The range was only 20 minutes. The median and the mean were very close together, 45 for the mean and 44.5 for the median. If we look at Mr. Bean's data, the second data set, we see that even though he had an average that was the same of 45 minutes, the range was much longer, 82 minutes difference between the shortest nap and the longest, which means that his data was more spread apart. We see that the median is 36 minutes, which is not as close to that mean of 45 minutes. There's another indication of the variance or the spread in the data that we're interested in looking at, and that's called the standard deviation. Now here's the formula for finding standard deviation. You do not have to memorize this formula. We're going to go through the steps to find the standard deviation for our data sets, but just know that we will be using technology to find the standard deviation and then interpreting the meaning of that. I'll say again that you do not have to memorize these steps, but you should be able to follow the steps when they're given to you to determine the standard deviation. So let's go through this together. Our first step is to find the mean of the data set, and we've already done that. So I'm going to write this over here. Our mean was 45 minutes. And we're talking about Mr. Bruss naps, and this was our first data set. Our second step is to subtract the mean from each value. So when we subtract, we go 38 minus 45, which gives us -7. And we do that all the way across, 40 minus 45, 44 minus 45. Then we have a difference of 0 for the next two, and 58 minus 45 is 13. Now notice that some of those numbers are positive and some of them are negative. To account for the difference in the signs and to make us less prone to error, we're going to square the differences. When we square a number, we get a positive number back, whether the number we start with is positive or negative. If we square -7, that's -7 times -7, which is a positive 49. If we square -5, we get 25. If we square -1, we get +1. If we square 0, we get 0. And when we square 13, we get 169. The next step is to add the squares that we found. So if we add 49 plus 25 plus 1 plus 0 plus 0 plus 169, we get a total of 244. That's called the sum of the squares. Now we want to divide that number by n minus 1. N is the number of items in our list. So we have 6 items in the list. We're going to subtract 1 from that. 6 minus 1 is 5. So we're going to divide 244 by 5. That gives us a result of 48.8. This is called the variance. So you'll hear that word again. Now we want to take the square root of that. When we take the square root of that number, we're going to get a long decimal. So the square root of 48.8 is 6.000. 98569, and that decimal would keep on going. We're not going to keep all of those decimals. Typically we round to the nearest tenth. So to round to the tenths, we're going to look at the number in the 100th place. Since it's bigger than 5, it's 8. We're going to round up the 9 to 10. When we round that 9 up to 10, it's going to change our 6 to a 7, and we're going to write 0.0 to show that that's rounded. Let's see how Desmos could find that for us without us going through all of those steps. Again, I've got my list in the first cell, and if I look at my function menu under stats, in the far right column it says mean and then max, and right under there is STDEV, which stands for standard deviation. So when I put that in there and tell it Y1, so here you see in that lower right corner that same standard deviation that we found by hand, and then we could round that as we already talked about. Now pause the video right here and go through those steps to find the standard deviation for our second data set about Mr. Bean's naps. Compare your numbers to the numbers that I got. You notice that these numbers are larger than the numbers that we got in our first data set as we went through this process, and that's a clue that there's more variance in our data for this data set than it was in the others. Now let's go to Desmos and see how we could get this automatically without doing all the steps individually. Rather than start from scratch, I just edited my table with my new data values in Y1. And as I did that, I didn't have to re-enter my commands at all. They adjusted automatically. So I see I have the mean of 45, which is the same as our other data set. But now I have a median of 36. And then my standard deviation I see is the decimal 29.95, and then that goes on forever. We want to round that to the nearest tenth, so it rounds to 30.0. So what does the standard deviation tell us about their naps? Well, we found that Mr. Brust had a standard deviation of 7.0 compared to Mr. Bean's standard deviation of 30.0. So the larger standard deviation tells us that there was less consistency, in other words, more variance in Mr. Bean's naps. Mr. Brust's naps with a smaller standard deviation was more consistent. The data was closer together. So the larger the standard deviation, the more spread out the data values are. Let's look at some examples of how algebra can be helpful for us when we're looking at statistics. In our first data set, we have a list of numbers, but one of the numbers we don't know, and it's x. We want to find x if the mean of this list is 12. We know that to find the mean, we need to add all the items in our list and divide by the number of items that we have. So we have 1, 2, 3, 4, 5, 6 items in our list, and when we find that mean, it has to be equal to 12. If we add the numbers in our list, then they add up to 52, and then we have our plus x that we can't combine with the numbers, and that's divided by 6 is equal to 12. To solve this type of equation, we want to multiply both sides by 6, which gives us 52 plus x is equal to 12 times 6, which is 72. Now we can subtract 52 from both sides, and x is equal to 20. So that's the number that's missing from our list for that list to have a mean of 12. On part B, we have a list with 4 items in it, and we know that the median is 27. Remember, the median is the middle number, and to find the middle number, I need to have my list in order. So the biggest number is 90, and then 25, and then x, and then 20. So it looks like they're in order from largest to smallest. That's fine. And I have 2 numbers that are in the middle, 25 and x. Since I have two numbers in the middle, I need to add them together and divide by 2. I need to average them. That would give me the median. And I know the median is 27, so I'm going to say that's equal to 27. Now I'm going to multiply both sides by 2 to get rid of the divide by 2, and that leaves me 25 plus x equals 27 times 2, which is 54. Then I can subtract 25 from both sides, and x is equal to 29. Next is your practice. Remember that you can use Desmos, but make sure that you understand the process of finding these things by yourself as well.